Hello, third graders. This is Mrs. Dale. I normally do my recordings on my dining room table, but my table is currently covered with end of the year stuff. And so I had to find a different way to do a lesson with you this week. So we're going to try this, and we're going to go through this slideshow to talk about this week's lesson. Now, this will be the last lesson for the school year. Did you hear that? The last lesson of third grade. Woo woo! You can go ahead and celebrate that. And this one is going to be about perimeter. So this is called Introduction to Perimeter. And you might ask yourself, is that a picture of a fence? And the answer is yes. Yes, it is. And we'll talk about why I used a picture of a fence for the perimeter opening slide in just a moment. But the last 2 weeks, you have been learning about area, the space inside a shape. You've been thinking about how much space a shape covers up, like an area rug. So if we were looking at this yellow rectangle, area would be the amount of space on the inside, how much space this is covering up. If this were a rug and laying on the floor, how much area is it covering? And today, we're going to be looking at something different. It's related to area, but it's different. It's perimeter. So what's perimeter? Perimeter is how far it is around a shape. And as I read this, every time I come to that word around, I want you to say it out loud with me. Think about a fence. A fence goes around a yard. The length of fence needed to go all the way around a garden would be the perimeter. So for example, I know a lot of people have been working in their yards this time of year. If this were going to be a new flower garden and you needed to know the perimeter of that garden, maybe to put a fence all the way around it, you would have to figure out how far it is to go all the way around the shape, all the sides. And that's why I picked the picture of a fence, because that's what perimeter represents. How far is it on the edge, all the way around? This is about how long something is. How long is it to go all the way around? So it's a different concept than area. We've been looking at shapes like this to find the area. And so last week we looked at shapes like this and we were thinking about our square units. And to find the area, we just counted individual squares. Or maybe we became really efficient and used our multiplication to find how much area. And so if we did that with a shape like this would be 2 squares, and then 1, 2, 3, 4, 5, 6, 7, 8. So 2 by 8, which give us an area of 16 square units. That's how much it's covering up. However, we want to find the perimeter, not the area on this one. So now we are going to be looking for, I don't know why that's giving a big red circle all of a sudden. We're going to be looking for how far around is this shape. And when we have squared shapes like this, shapes that have the square units visible to us, we can count the edges to find our perimeter. How many sections is it if I go all the way around? All 4 sides in this case, because it's a rectangle. So I'm not going to be counting the squares, I'm going to be counting the edges. If this were a yard, our squares would be patches of grass that lay out flat and take up space, but the edges would be maybe sections of fence that we would need to go all the way around it. So we're going to be counting these sections to find our perimeter. Now I created this red dot and I'm going to move it over here. And that's just going to be a reminder for me about where I'm going to start counting and where I need to stop. Because otherwise you might start counting and go all the way around and then start counting the same side again. So I just like to put a little dot there as a reminder of where I'm beginning and then where I need to stop. So I'm going to start here and I'm going to count my sections. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. We still need to have fence on the ends. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I'm going to stop there because that was where I started counting. That's what my red dot means. So if I just used counting to find the perimeter of this shape, the perimeter, I'm going to use P for perimeter, equals 20. Now, I don't know if these are inches or squares or inches or feet or miles or meters. So I'm just going to say the perimeter is 20. We counted the sections all the way around. But just like with area, we might get a shape that doesn't have squares that we can just count, but it gives us some dimensions. So this would be a fair question. What is the perimeter of this shape? Now, we are not responsible for just finding perimeter of a rectangle. We're responsible for finding the perimeter of any polygon, any shape that's closed in and has straight sides. So let's see how far it is to go all the way around this shape. That means we have to make sure when we're finding our perimeter that we add up all the sides. Think about this as a fence that's going to be keeping in a dog. If we don't put a fence on every single one of these sides, it's not going to keep the dog in. So let's think about how many numbers are we going to be counting up? How many sides are there on this shape? So let's see, there's 1, 2, 3, 4, 5, 6 sides. So that's why over here I put this kind of blank equation showing that we're going to add up the 6 sides, 1, 2, 3, 4, 5, 6, and that's going to tell us the perimeter, how far it is all the way around. And these measurements are in feet. So when we get an answer, we're going to know how many feet it is all the way around this shape. Okay? All right, so we're going to create our equation here. We're going to start with this side here. It doesn't matter which side we start with as long as we use them all, because we can add in different order and still get the same sum. So here we go. 4 plus, and now I'm going to go to this one, 4 plus this one, 6 plus another 4 plus, oops, down here to this one, 10 plus, and another one over here, 8. And that's going to tell me my perimeter. So I'm going to double check. I know that there are 6 sides here. So that means I should have 6 add-ins. So I'm going to make sure I put 6 add-ins. 1, 2, 3, 4, 5, 6. That's a good check to make sure you haven't left a side out. All right, now it's time to add them up. Now, you could just start here and do 4 plus 4 plus 6 and just add them up. That's fine. Or you might see something in here that you know you could put together. Like I see this right here, 4 plus 4. Let's see if I can find my highlighter really quickly. 4 plus 4, I know that that's 8. So I'm going to put those together. I like what I see next. Look at this. 6 plus 4. You know I like that one. Those are best 10 friends. There's a 10. I like it when I can make a friendly number. And then I've got 10 and 8. So I'm going to do plus 10 plus 8. Oops. Plus 10 and 8, which is 18. And I'm getting closer to finding my perimeter. All right. Here we go. Now, you might be able to do all this in your head, and that's just fine. I'm just showing how I would think about adding up so many pieces at one time. So I can see I've got 8 plus 10, which is 18, and I'm adding it to another 18. So 10 and 10 is 20. And 8 plus 8 is 16. 20 plus 10 is 30. Plus 6 more is 36. So our perimeter is 36 feet. That's how far it is all the way around this shape. And I could check it. 4 and 4 is 8. I can go this way. 4 and 4 is 8. I'm going to double it with another 8 and get 16. Plus 10 more is 26. Plus 4 more is 30. Plus 6 more is 36. So it's always good to check your thinking. All right, so let's take a look at a different one. Here we go. We just have a rectangle. The question is, what is the perimeter of this rectangle? And there are 4 sides on a rectangle. I know you know that. But at first glance, it might seem like you can't answer this question because to answer a perimeter question, we have to add up all of the sides, all 4 sides in this case, because it's a quadrilateral. 1, 2, 3, 4. And you might think, I can't do that, Mrs. Dale, because they've only given me 2 sides. And they have only written the sides twice, one time for the length, one time for the width. But I want you to think about what you know about a rectangle. And rectangles, the opposite sides are parallel, and they're also the same size. When we draw a rectangle, this side is the same size as this side. So they've told us 5 here, which means this one down here also must be 5 inches. And we still have this side over here, and it's not a mystery because we know that this side is 8, which means on a rectangle, the opposite side must be the same length. So if I type those in, now I can see I have a quadrilateral that's 4 sides, and now I can see my 4 dimensions. And I can use it that way. You might have thought about how to use it just knowing those 2. And if that's the case, that's great. But most of us would need to write those 4, see those 4, and then think about using all 4 when we write our equation. So I'm going to put them in there in a way that uses all 4 of them in an addition sentence. So I know I had 2 sides that were 5 and 2 sides that were 8. And if I add all of those together, it's going to tell me the perimeter, how far it is all the way around, how many inches it is all the way around this rectangle. All right, I know 5 and 5 is 10, and 8 and 8 is 16. And so now I'm getting closer to a total. 10 plus 10 is 20 plus 6 more. 26 inches is the perimeter. So it might seem like you don't have enough information, but if you think about what you know about a rectangle, you do know the rest of those dimensions. So you can go ahead and include them and then use them to find the perimeter. All right, a square. I know you know a square is a quadrilateral. I know you know that that means that there are 4 sides to this shape, but they've only given us 1. But what is true about all squares? And I know that you all know this because you've all worked so hard on your classifying quadrilaterals lesson, that what makes a square so special is that it has 4 sides, has 4 right angles, and it has all sides the same length. That means if this is a 10-meter side, then this side is 10 meters. This side is 10 meters. And this side is 10 meters. So we do actually have enough information to figure this out because we used what we know about squares to fill in those dimensions that seem to be missing. So you might think something like this: 10 plus 10 plus 10 plus 10. That's going to tell you your perimeter. and then add them up. 10 and 10 is 20, plus another 10 is 30, plus another 10 is 40. And so this is 40 meters equals the perimeter, just using the units that were given. But I also want you to think about what you know. There are 4 sides to each square. They're all the same sides. They're equal groups. So we could have 4 sides of 10 meters. You could think about it that way because they're all the same. And 4 times 10 is 40. So our perimeter would still be 40 meters. So on a square, you could start thinking about using multiplication to find the perimeter, how far it is to go all the way around the edge. Not how much space is in the middle, how far it is all the way around. Okay, those are very different measurements. I'm going to go back to this one, and I want you to think about that. We said that the perimeter was 26 inches to go from here to here, here to here, here to here, and here to here. It would be 26 inches. That's a really different measurement than the space covered on the inside of this rectangle, the area. Think about that. We talked about using our multiplication to find our area. So 8 times 5, I love a 5, 5, 10, 15, 20, 25, 30, 35, 40 square inches is the area. That's really different than 26 inches being the perimeter. So area and perimeter are connected to each other, but they're very different ideas, and they're different measurements that tell us different things. On our square, we said the perimeter, the length all the way around, was 40 meters. But we could also see that we could use our multiplication to find our area. Let's see. 10 times 10 is 100 square meters. Our area is 100 square meters, but our perimeter is 40. So these are very different numbers telling us very different things. The area tells us the amount of space on the inside that we would color. The perimeter tells us the outline. How far is it to go all the way around that shape? Okay, so we can get to more challenging questions about perimeter with something like this. What if I told you the perimeter of this shape is 17 feet? Can you find the length of this missing side? So think about what that means. The perimeter is 17 feet. That means to walk all the way around this strangely shaped yard, it would be 17 feet. And we know how big 3 of these sides are. And the question is, how big is this one? So this is really the equation we're solving. We're solving this. 4, that's one side that we know, plus 6, that's another side we know, plus 4, that's the third side we know, plus something equals, and we know the perimeter is 17. It was given to us. So we're thinking about what's that missing add-in? How much are we missing if we add these up, if we still want to get to 17? So let's continue our thinking down here. Well, 4 and 6 is 10. So I can put those together. I'm doing, there's my other 4. Oops, gosh. And I know when I add them up, it's going to equal 17. All right, 10 plus 4 is 14. So now I'm asking myself, 14 plus what equals 17? And I can count up. Imagine this were a number line. I don't think I can draw a number line really quickly. Let's see. I know I love a number line. If this was a number line, make that line nice and thick so you can see it. Oh, that's too thick. And I'm going to start at 14. And I'm going to see how many moves I need to make to get to, crazy little text box there. We'll start it. This is what I get for trying to improvise last minute. I didn't make a plan for this. Let's see if I can make it work here. I'm at 14. And I want to see how many it's going to take to get to 17. So I don't know if I have any crazy little shapes that's going to help out with that. Let's see. Maybe this one. Let's see if we can make this work. All right, I'll do it. That'll do for me. Here we go. So there's 1. So that's going to get me to 15. I'm going to jump again. That's going to get me to 16. I'm going to need to, oops. I'm going to need to jump again. And that's going to get me to 17. So that means I can't jump 3 times. 1, 2, 3. That's our missing side. Our missing side equals 3. 3 feet. Let's see. Let's do another text box here. Let's type in an answer. Our missing side is 3 feet. Okay. Here we go. There's our missing side. So we can, if we know the perimeter, we can add up the sides we know and then see how much more do we need to add to get our total perimeter. All right, so here's another one. And I'm going to read this, and then I want you to pause your video and try it on your own, okay? The perimeter of this pentagon is 40 inches. What is the missing side? So go ahead and pause it and try to figure it out and come back to check your thinking. Okay, I hope you got some work in to check. So we're going to add up the sides we know and see how much more we need to get to our given perimeter of 40 inches. So we have 7 plus 7, oops, plus 9 plus 9. And we're going to add that to something, and it's going to equal the perimeter that they gave us. It's going to equal 40. Okay. All right, 7 and 7 is 14. I like these doubles. 9 and 9 is 18. And we're still missing that piece. Plus something equals 40. Now I'm going to break apart this 14 and 18 to add it together. 10 and 10 is 20. 4 and 8 is 12. Still have a missing piece. I don't know what that missing side is yet, but when I add it to it, it's going to get to be the perimeter of 40. All right, now I'm going to add these two together. 20 plus 10 is 30, plus 2 more is 32, plus something, that missing side, is going to give me a perimeter of 40. So 32 plus what equals 40? And that's a best 10 friend situation. We're getting to the next 10 and we've got a 2 in the ones place. So the best 10 friend for 2 is 8. So our missing side, here we go. And let's make this red so we can see it. Oh, okay. Missing side is 8, and our units are inches. There we go. Okay, so we added up the sides we knew and figured out how much more we needed to add to get to our given perimeter. All right, you might get a question that looks something like this when you work through your lesson in your quiz, and it might give you several shapes and ask you to find which ones have the same perimeter. Now remember, we're talking about perimeter here. We are not talking about area. So to find the perimeter of this rectangle, We use what we know about rectangles, and that means we're adding up 3 plus 3 plus 4 plus 4, and it's going to give us our perimeter. So 3 and 3 is 6, plus 4 is 12 or 10, plus 4 is 14. So the perimeter on this one is 14. Let's work on this one. Here's my box. There it is. All right, I'm going to add them up. 6 plus 2 plus 6 plus 2. I know my other sides. I know this side is 2 and this side is 6 because of them being equal to the opposite sides, like a rectangle. All right, 6 plus 2 is 8. 6 plus 2 is 8. And double of 8 is 16. So these two have this, do they have the same perimeter? One's 14 and one's 16. These do not have the same perimeter. So let's check out the perimeter on this one. 1 plus 1 plus 6 plus 6. All right, let's figure that out. 1 plus 1 is 2, plus 6 is 8, plus 6 more is 14. So the two with the same perimeter are this one and this one. They both have a perimeter of 14. And what's really important is to make sure you're not thinking about area when you answer this type of question, because look what happens if you do. The area of this one, of a 3 by 4, is 3 times 4, which equals 12. So the area of this one would be 12. Let's think about the area of this one. 6 times 2. What is 6 times 2? 12. Those two have the same area. Look at this one. 6, 1 times 6. 6. So these two have the same perimeter, but they don't have the same area. This one has an area of 6. This one has an area of 12. But these two, they have the same area. They both cover the same amount of space, 12 square inches, but their perimeters are different, 14 and 16. So you have to be careful to make sure you're using the measurement of perimeter to decide a question like this, because if you're using area, you're going to pick these two, but it's not asking for which ones have the same area. It's asking for which two have the same perimeter. Okay, last one, real life problem. Mark has 60 feet of fencing to make a new play area for his puppy Poof Ball. Does he have enough fence to go all the way around? So we're going to have to add up the perimeter of Poof Ball's play area and then ask ourselves, if Mark has 60 square feet, does he have enough? So I want you to pause this, figure out the perimeter of Poof Ball's play area, and be ready to answer that question of, does Mark have enough fencing? Okay, I hope you got some good practice in. So really what we're solving is 11 plus 11. I like to put those matching numbers close to each other when I write them down, just because sometimes they're easier for me to think of as doubles. But you could write these numbers in any order. We know that because of our addition properties. 3 plus 2 is the same as 2 plus 3. So you can write your addition in any order you want. I know that 11 doubled is 22. And I know that 15 doubled is 30. So that's why I like to write them like that, because I can figure out those doubles pretty quickly. If you didn't, you could use your tens and ones and break apart and lots of different strategies. All right, now I'm going to add my tens. 2 tens and 3 tens is 5 tens, so that's 50. And then my ones, 2 plus 0 is 2. Oh my goodness. There we go. All right, last calculation. 50 plus 2 is 52. So 52 feet is the perimeter for Poof Ball's play area. And Mark has 60 feet of fencing. So does he have enough fence to go all the way around? Go ahead, yell it out. Make it big. Let's see. Let's make it big. Yes, he does. He has 52 feet and he has 60 feet and he only needs 52 feet. So he has more than enough to make Poofball's play area, the fence around it. All right, guys, I hope this was helpful. I will get this posted. I hope you use it. I want you to know I miss you, and I can't believe this is our last lesson. So we'll see you soon.